Okay, thank you. I want to thank SK Planet for having us out here to talk about something so interesting. So, as we mentioned, I'll be talking about Newsfeed today, and I'll be hopefully giving you guys a sense of exactly how it works. That's kind of my goal here. And it's not really just Newsfeed. When we've developed these technologies, they're really things that focus on what we call the social graph, and I'm sure that's a term that you guys have heard in your daily lives. But really, when we think about the social graph, it's a real thing. It's a real thing that we store in our servers, that we query, and that we think about in a very real engineering sense. So today's talk is, as appropriately titled, Social Data at Scale. It's kind of a custom at Facebook. When we want to introduce ourselves, we use the same mechanism to do so that we would on the site. So here's a look at my Facebook profile as of yesterday. I've worked on Newsfeed, and I live in New York. Those are kind of the highlights. Social feeds. A very common pattern at Facebook is that we want to show you some information about the local piece of the social graph that belongs to you. So just a refresher, the social graph is something that we originally thought of as this abstraction of the fact that you have connections to other people, and those people have connections to each other. And so originally we thought about people and the people they're friends with as this giant graph that connects everybody in the world. But increasingly these days, the graph also includes things like brands, political figures, anything that you can think of that might have a relationship to a person, we think of as part of the social graph. So a very common thing that we want to do to render one of our pages is take your node in the social graph. We want to look at all the nodes that surround you, all the things that you're connected with. From those things, look at all the new and relevant things that they're connected with, be they pieces of content, other individuals, whatever, and surface the most relevant stuff so that you can live a better life. Newsfeed itself, so for those who aren't familiar, Newsfeed is the center column of the homepage on Facebook.com, and it's this scrolling log of all the things that your friends are doing and all the things that we think you might find interesting happening in your social circle. So when we think about Newsfeed, from an infrastructure standpoint, we think about it as this process. First we want to fetch all the recent activity from your friends in the graph. Second, we want to gather all that stuff in one place so we can consider it holistically. Third, we group it into individual stories that may represent lots of activity, 5 people talking about the World Cup or something. And then we want to rank it by how interesting we think you'll find it, and then we want to return it and present it to you on a web page or on one of our mobile apps. And the thing that makes this tough is the scale at which we operate. So Newsfeed itself will do tens of billions of queries a day. Each of those queries will have to respond in less than 60 milliseconds. And we only really get to fail before people start noticing about 1 out of every million times. And we do all of these things routinely every day, so these are very real numbers about the scale of Newsfeed. So how do we do it? That's the big question. And I want to pause here to not only talk about the scale of Facebook itself, but to talk about the scale of our engineering organization. So when I joined Facebook, it was about 5 years ago, and we had 80 engineers. And now we have, I think, on the order of 1,100 engineers. And every year, from the day that I started, we have increased the ratio of users to engineers, meaning the amount of physical load that we support, the amount of feature and just physical capacity to serve people Facebook that every engineer is responsible for has actually gone up every year. And that means you'll see a lot of themes in our presentation about being nimble, about being sort of startup-y, and about doing things at very high leverage, because we don't really have much of a choice. Our engineering organization is very good, but also very small for the tasks that are put before us. So how do we do this giant problem of serving people news feeds? Well, there are 2 basic models that we looked at. And I think a lot of people in the room, if you are building feed-like features, this will speak to you because you've probably thought about this as well. A lot of startups these days and a lot of products come with feeds baked into them. So there are 2 kind of basic models for how you can build feeds. The first one is that I could broadcast everything that you do into a log to all of your friends. So if you update your status, if you post a photo, I can make sure that all of your friends get a record of that so that they can view it later. We call that Megafeed because it's a megaphone of sorts. Multifeed is a little bit different. When you take everything that you specifically have done and we write it in a log just for you. And then when one of your friends asks us, well, what's going on in my social network, we take all of their friends and we fetch all of the logs for all those individual users and we create on the fly a feed for that specific user. And so each of these have different problems that you engineer around. Going back to Megafeed, this involves this giant write amplification. For everything that happens, we're going to write it to everybody's logs. And that involves lots of storage. But it's relatively simple when you go to read what's going on in your newsfeed. This multi-feed model, it's relatively easy to write something to one log. But then we have this aggressive aggregation, ranking problem to do in a relatively short amount of time. And at Facebook, we've decided to use multi-feed, which is the second model, which means that every time you hit the homepage, we're getting all the things about your friends live and calculating what you should see in real time. And that has a bunch of advantages, some of which are sort of subtle. First of all, the storage requirements are a lot less onerous. And that means that we can engineer the whole system around things like RAM and network and flash, things that are easier to deal with and things that fail less frequently than spinning disks and giant data centers filled with them. It also means that our development cycle can be really, really tight. So if you, because we're rendering everything live, because our algorithms run completely in real time, if you want to make a change to the way newsfeed works, you make that change, you recompile your code, and you see the result of that change in seconds. And if you think about some of you in here, I'm sure a huge percentage are actual developers. If you think about how much it matters that you can make a change and see it immediately versus having to go through and run some sort of background process to look at the results of your code. This makes products much better. And we firmly believe that any way that we can speed up our developers is going to result in better experiences for users. Finally, we have this problem that I lovingly call the Justin Bieber problem with the Megafeed approach, and I think a lot of services, when they start with Megafeed and they run into this problem, which is when Justin Bieber, who has millions and millions of fans on Facebook, I think he has something like 70 million fans, when he decides that he wants to upload a photo, if you have to write 70 million records, that's a tremendous challenge. That's something that is hard to engineer around. Whereas on the flip side, no one person is really friends with 7 million people. So we can much more tightly bound the things we have to do at read time than we can at write time. And that's a subtle but significant advantage of doing things the way we do them with multi-feed. So what does this look like as a general architecture? You can see that the data that we have, here we have two main parts. We have these sets of leaf nodes that come in a set. Where all of the user data across the entire site is sharded across one set of them. And we have this stateless thing called an aggregator that will gather all that data and do all the nitty-gritty of ranking. You can also see that these leaf nodes, in addition to coming in sets, also come in multiple replicas of that same data. So at any given time, we're running tens or hundreds of copies of all of the activity in the entire site in these sets of leaf nodes. So that they can be pulled as quickly as we can. And we really do mean quickly, just to sort of talk in depth about the technology. As I mentioned, we do tens of billions of queries to the aggregator itself, but because of that fan out, that means that those leaf nodes are doing hundreds of thousands of transactions a second. They're really operating as kind of the limit of what the hardware will allow them to. They're all basically single machine, extremely high performance databases. And they're surprisingly small amounts of code. Going back to how we build things and how many engineers we have to apply to problems like this, having a very small code base is actually a huge advantage to us and not something we're actually sort of proud of. The other thing is that this type of system can power anything that looks like grabbing things out of your local section of a graph. So we don't just use it for newsfeed, we use it for lots of other projects at the site. There are some things that I'm sure are very interesting, but we probably won't have time to go into. I just wanted to acknowledge them here. We do all this across data centers that span the entire globe. So we have data centers in Sweden, we have data centers on the East Coast of the United States, we have them sort of all over the world. And unfortunately, the speed of light is a significant factor when you think about doing things with such great distances. So doing this in multiple regions around the world is definitely an additional challenge. We push new code to a system like this with thousands and thousands of machines pretty much daily. And there are a lot of things that we've done to make that good. But again, not something we're going to have time for. How we determine what we think will be interesting to you. I mean, this is just a really deep piece of social science, but unfortunately we won't have time to talk about ranking. And then just dealing with disasters and dealing with failure and keeping things up even through hurricanes and stuff like that. Not something we're going to have time for. So how do we store these things? We talked about having single node databases. How do they work? The first thing we think about when we're looking at some data and we want to store it is what indexes do we need over it? How are we going to access it in the future? So it's pretty clear that for feed, we have a pretty simple set of indexes that we want to keep. We want to take all of the users on the site and kind of split them across a bunch of machines. We know we can't do everything on one machine, so we split them up just based on a random hash function. And for each user, we want to be able to go through all of the things that user has done recently